Welcome to The Explainer. Today, we're going to break down this really fascinating new framework for artificial intelligence from researcher Anthony Pyper. The big idea here? Creating a machine that can literally evolve its own way of thinking. You know, this is probably one of the biggest questions in AI, period. And it really gets at this deep conflict right at the heart of the whole field. I mean, how do you build something that's super smart, but also something you can actually trust? Okay, so to really get why this new approach is such a big deal, we've got to first talk about the two, let's call them personalities, that pretty much run the show in AI today. So on one hand, you've got what we can call the rule follower. Think of this as your old school symbolic AI. It's super precise, totally safe, and you can follow its logic step by step. The downside? It's so rigid. Give it a new problem it hasn't seen before, and poof, it just falls apart. Then, on the other hand, you have the pattern matcher. This is your modern LLM. These things are incredibly flexible, they can be creative, they're powerful, but, and this is a huge but, they're often a total black box. You don't know why they say what they say, they're unpredictable, and sometimes, let's be honest, they just spit out nonsense. So the million-dollar question has always been, can we get the best of both? So, what if you could actually do it? What if you could build a single system that has the strict logic of that rule follower, but also the creative juice of the pattern matcher? Well, that's exactly what this framework we're looking at today is trying to do. It's what Anthony Pyper calls it a unified consciousness simulation. Basically, the idea is to have one system where thoughts are born creatively, but then immediately get checked against some really strict rules. It's like having a brainstorming session and a fact checker all rolled into one. So the real goal here is to create an AI where the thinking process isn't some big secret, you know? We want a system where we can actually look under the hood, trace an idea from its birth all the way to its conclusion, and, this is the big one, actually trust what it's telling us. Okay, so let's get into the nitty-gritty. Let's follow a single thought as it makes its way through this new kind of AI mind. All right, the whole thing is set up as this crystal clear, auditable loop, and we can break it down into four main stages. It's this structure, this loop that makes the whole system transparent. So, an idea gets generated. Then, boom, it immediately hits quality control. If it makes the cut, it gets a score for how valuable it might be. And finally, it's carefully filed away into this really cool memory system. So let's walk through it, starting with that all-important quality control step. Okay, so as soon as a potential thought is generated, maybe as one branch in a whole tree of thought, it runs smack into this super strict gatekeeper. And we're not talking about some fuzzy, this looks okay kind of check. This is a formal system, a DFA recognizer that acts like the world's toughest grammar checker, but for thoughts. It makes sure every single idea is structurally perfect before it goes anywhere else. And this is absolutely the system's first line of defense. If a thought is just malformed or makes no sense, it gets tossed out immediately. No second chances. And this is just a brilliant move because it stops the AI from wasting a single cycle on garbage ideas. It bakes safety and logic right into the system from the get-go. All right, so a thought passes the grammar check. What's next? Well, now it has to face the value judge. This is a neural network, so it's learned from past experience. It takes that perfectly formed thought and asks a really simple but crucial question. Okay, it's structured correctly, but is it actually useful? Does this thought have any real value? And the judge gives it a score. Right here, we see 0.85. The cool part is, over time, through trial and error, this judge gets smarter. It starts to recognize what kinds of thoughts actually lead to good outcomes, so it learns to favor ideas that are more likely to be winners. And finally, if a thought makes it through all those checks, it gets stored in this incredible multi-part library. This is so important for transparency. First, there's a red-black tree, which is basically a super fast card catalog for every thought so you can find anything instantly. Then you've got a QuadTree. Think of this as a conceptual map that puts similar ideas close to each other. This is how the AI can make those creative leaps and connect different concepts. And last, there's something called binary lifting, which is like a family tree for every single thought. It lets you trace an idea all the way back to its origins and see how it developed. This whole memory system is really the key to being able to audit the AI's reasoning. Okay, but here's where it gets really interesting. The system doesn't just have good thoughts and call it a day. No, it goes a huge step further. It actively tries to get better at the process of thinking itself. And this is what makes it a living, breathing system, not just a static program. It's designed to evolve. And there are two main engines driving that evolution. First up, you've got a built-in genetic algorithm. The best way to think about this is like the AI has its own internal research and development department. It's constantly running little experiments, trying out new thinking styles or genomes to see what works best. It's literally survival of the fittest, but for thought processes. And this part is just fantastic. It really shows you how autonomous this system is. It has a self-modification protocol. What does that mean? It means the AI can actually look at its own performance and tweak its own settings. It can decide, hey, I need to be more creative and dial up its mutation rate. Or it could say, I need to be more careful and slow down its learning. It is literally fine-tuning itself to improve over time, all on its own.
Okay, so let's pull back for a second. What does all of this actually mean? Why is building an AI like this such a potential game changer?
I mean, this table pretty much lays it out. If you look at a traditional LLM, interpretability is basically zero. It's a black box. But with this framework, it's super high. Every thought is auditable, which is crucial for things like science or medicine, where you have to know how the AI got its answer. And safety? With LLMs, it's a roll of the dice. Here, it's baked into the design thanks to that gatekeeper we talked about. And self-improvement? LLMs need humans to tune them. This system does it automatically. It's a completely different philosophy. So really, what Anthony Pyper's framework is all about isn't just making a machine that can spit out text. It's about building what he calls a curator of admissible reasoning trajectories. That's a fancy way of saying the focus isn't just on the final answer. It's on building a trustworthy, transparent, and logical path to that answer. What we're looking at here is a really compelling blueprint for an AI that can learn and judge and adapt, but in a way that we can always understand and inspect. And it leaves you with a pretty big question, right? Could this be the beginning of the first generation of thinking machines that we can finally, truly hold accountable?